Let's explore the redo logs in InnoDB diagram interactively by diving into its key components and workflows. 1. What are redo logs? Redo logs are a critical feature of InnoDB, ensuring data durability and enabling recovery in case of database crashes. Think of them as a diary of changes, where every modification to the database is logged sequentially before being written to the actual data files. 2. Key functions of redo logs. Durability. Before any changes reach the disk, redo logs capture them. This ensures that even if a crash happens, the database can recover without losing committed transactions. Write-ahead logging. Changes are written to redo logs before they are applied to the actual data files. This guarantees data integrity by always having a record of committed transactions. Crash recovery. When the database restarts after a crash, InnoDB uses redo logs to replay committed transactions that weren't flushed to disk, discard incomplete transactions, maintaining a consistent state. 3. How redo logs work. 1. Transaction begins. When a user modifies data, changes are first written to the redo log buffer in memory. 2. Log buffer flush. Periodically, this buffer is flushed to redo log files, e.g. IB log file 0, on disk for durability. These writes are sequential, making them extremely fast. 3. Checkpointing. InnoDB marks a point in the redo logs where all changes have been applied to the data files. This reduces recovery time during crashes. 4. Cyclic writing. Redo logs are written cyclically. When the end of a log file is reached, writing resumes at the beginning after clearing old data already applied to the database. 4. Why redo logs are efficient. Sequential writes. Instead of random writes, common with data files, redo logs are written sequentially, which is much faster and ideal for modern storage systems. Bulk data writes. Changes are batched and written in groups, minimizing disk I/O and boosting performance. Number 5. Components of redo logs. Redo log buffer, a temporary memory area that holds redo log entries before they're flushed to disk. This is a critical step in ensuring that writes to disk are efficient and fast. Redo log files, persistent storage for redo logs on disk, such as IB log file 0 and IB log file 1. These files are configured based on parameters like InnoDB log file size and InnoDB log files in group. 6. Workflow example. Imagine a user updates a record in a database. 1. Modify data. The user modifies a table, and the changes are recorded in the redo log buffer. 2. Log before write. Before updating the actual data file, the redo log captures the change. 3. Commit. The transaction commits, flushing the redo log buffer to disk. 4. Data write. The data files are updated asynchronously during checkpointing. 7. Key configurations. InnoDB log file size defines the size of each redo log file. Larger sizes can improve performance for large workloads. InnoDB log file scores in group specifies how many redo log files exist in the group. InnoDB flush log at TXRX commit controls when redo logs are flushed to disk. For example, value 1, flush immediately on commit, maximum durability. Value 2, flush periodically for better performance. 8. Importance of redo logs. Data integrity ensures that committed transactions are never lost, even during unexpected crashes. Performance. Sequential writes and bulk operations make redo logs efficient. Scalability. Handles high concurrency environments and large workloads with ease. Conclusion. Redo logs act as a safety net, ensuring both performance and reliability in InnoDB. By logging every change before it's written to the database, they provide a robust mechanism for crash recovery, durability, and consistent data management. Ready to dive deeper? Start by tuning InnoDB log file size and exploring your database's recovery process.